AI trends move fast. Every year, new ideas explode, and some disappear just as quickly. In AI, the hottest topic today might be forgotten tomorrow. In this video, we are talking about one of those ideas, capsule networks. Capsule networks were introduced by Geoffrey Hinton, often called the godfather of neural networks. His goal was to fix a fundamental weakness in convolutional neural networks, or CNNs. CNNs don't truly understand the spatial relationships. A CNN can detect that a face is in an image, but it doesn't really know if the eyes and mouth are in the wrong places. It just looks for pattern, not structure. Capsule networks tried to fix this. Instead of detecting features independently, capsules group features together and encode their position, orientation, and relationships. In theory, a capsule wouldn't just detect an eye. It would also understand where the eye is, how it's rotated, or whether it fits with the rest of the face. Hinton believed capsules could eventually replace CNNs, offering better spatial reasoning, strong robustness, and even resistance to adversarial attacks. When Hinton's dynamic routing between capsules paper was published in late 2017, the deep learning community erupted. Capsule networks suddenly became one of the most exciting new ideas in AI. Early demos were eye-catching. Capsules recognized objects despite rotation and distortion. They handled occlusion better than CNNs. They seemed more human-like in reasoning. The research world surged with energy. Blog posts called Capsules, the future of deep learning. Labs raced to reproduce the results. Conference talks were packed. New variants and improvements were published almost weekly. For nearly a year, capsule networks were everywhere. They represented something rare, a brand new architecture that challenged the dominance of CNNs. Expectations were sky high. But as more researchers tried to scale capsules, the enthusiasm hit reality. Major problems started to appear. The first problem is it is extremely slow and unstable to train. The dynamic routing algorithm sounded elegant, but in practice it was heavy, fragile, and slow. The second problem is poor scalability. Capsules works on small datasets like MNIST, but failed to scale to large real-world datasets like ImageNet. The third problem is competing architecture improved faster. While people struggled to make capsules work, CNNs kept improving and transformers emerged, completely changing the field. Capsules weren't just slow, they were falling behind every month as other architectures advanced at lightning speed. The hype faded, research papers dropped off, and the industry quietly moved on. Today, capsule networks are seen as a brilliant idea that never reached practical maturity. A few researchers still work on them, mostly in niche areas like medical imaging. But there are no mainstream models using capsule networks. They are not competitive with modern CNNs or transformers. The deep learning community has largely shifted to architectures that are more scalable, stable, and easy to train. Capsules now sits in a unique place in AI history. A visionary concept from Hinton, full of potential, but ultimately overtaken by faster, more practical architectures. They are not completely dead, but they are dormant, waiting for a breakthrough that might one day bring them back.